Good morning. Today we're going to be talking about half-life, kind of the opposite of doubling time. That's going to be the time it takes for a quantity to decay to half of its original amount. And we have a formula that's very similar to the one we worked on yesterday. The only difference is instead of a 2 here in the parentheses, we've got the fraction 1/2, or if you want to use decimals, I would use 0.5. Again, that would probably make it easier on your calculator to just go ahead and use 0.5 in that spot. All right, where m is our final quantity, how much do we have at the end? M sub O is our initial quantity. And then again, the T stands for time, and H is half-life. And the time and half-life need to be measured in the same unit. So if the half-life is in days, then our time needs to be measured in days. Those things need to be similar. All right, so again, let's talk about what this idea of half-life means. Again, it means, let's say we start off with something that we've got, let's say we've got 200 of something. That's our count. And if, let's say, our half-life is 1 year. Well, that would mean that's as our m sub 0. It starts off at 2,000. And then after 1 year, we would have half of that, down to 100. All right, after 2 years, we would have half of that half, 50. And if you took it 50 out of 200, you would find out that that is 25%, or 1/4. And then we add another half lifetime, another year goes by, and half of 50 is 25. And again, if you wanted to break that down, 25 out of the original 200 is 1/8. And then after 4 years, we have half of 12 or 25, which is 12.5. And again, 12.5, if you divide it by 200, you get a fraction 1/16. Notice again that we went from a whole to 1/2 to 1/4 to 1/8 to 1/16. So it's almost the opposite of doubling. The denominator is doubling, not the numerator. And again, we could keep going. After 5 years, we would be half of 6.25, which are 12.5, which would be 6.25. That's the answer. And again, eventually, if we continued this pattern, eventually you'd get down to essentially having 0. So eventually these things will decay all the way away. But that's the idea. That something is decaying, it's disappearing at a constant rate. It's called a half-life. We can use this formula to find out information. So let's do a couple of examples. And they're going to be heavy on the calculator at some point, so you're definitely going to need a calculator with you when you do your work today. So this one says the half-life of ethanol is 4.5 hours. If you don't know what ethanol is, it's the part of the alcohol that gives you the intoxicating effects. So a can of beer contains 14 grams of this ethanol in the alcohol. So if someone drinks 6 beers, how many grams of alcohol would still be in their system after 9 hours? All right, so let's go ahead and work out this formula. So our m is our ending result. We're trying to figure out how much that is. Our m sub 0 is our initial amount, and we do know that, how many we drank. So if each can has 14 grams of this alcohol, and we had 6, well, we times 6 by 14. So we have an initial amount of 84 grams. If you want to put the grams in there, that's fine. You don't need to, though. I'm going to leave it off. We know we're measuring in grams. All right, then the formula says 1/2, so that means we're going to use 1/2. But again, if I'm on a calculator, I'm probably going to use 0.5. And then the T over H. All right, so that's the time. So the half-life is measured in hours, so it's about 4.5 hours. So we want to have everything in hours. The time is 9 hours, and the half-life is 4.5 hours. Now again, to make things simpler on my calculator, I'm going to go ahead and do that division right now. 9 divided by 4.5 is 2. This is going to be 2 half-lives, which honestly, we could do this by hand. If we know how many half-lives it's going to be, 2, so we could take 84 and divide it in half to get 42, that's 1 half-life. Divide it in half again to get 21, there's 2 half-lives. That's what the answer should be. But let's make sure the calculator does it right also. So 84 times 0.5 raised to the second power. No, it was correct. I got 21. Well, 21 what? Oh, 21 grams. Well, let's think about that for a second. 21 grams, well, there's only 14 grams in 1 can of beer. 21 grams, that'd be like 1.5 cans of beer. So 9 hours after this person drank their 6 beers, they still have enough alcohol in their system as if they drank 1.5 beers. Which is why people who drink alcohol, stay up late at night, should not be driving in the morning. If you go driving in the morning, there is still enough alcohol in your system to register on a breathalyzer if you ever get pulled over. So just something to think about as you get older, because clearly you're not old enough to drink alcohol at this point, but later on maybe you'll decide that you will choose to drink. And if so, driving 6 hours, 8 hours after drinking a bunch of alcohol is just as bad as driving while drinking. You can absolutely get in trouble for that. So just something to be aware of going forward, that it takes a while for the alcohol to clear out of your system. All right, let's try one more. The half-life of carbon-14 is 5,730 years. So have you ever heard of carbon dating? This is how it works. There is a little short YouTube video I attached to today's page. It's only like 2 minutes long. That does explain the carbon dating process if you're curious more about this specific problem. So if there's a sample with 10 grams of carbon-14 today, how much carbon did that sample have 20,000 years ago? So this is kind of reversing things around a little bit. So again, let's look at our original formula here, and let's set things up with what we have. All right, we know how much carbon there is today, 10 grams of carbon. We have the final answer. What we're missing is this m sub 0 number. How much did it have a long time ago? We're missing the original amount. All right, well, we have that 1/2. We know the time. It's been 20,000 years. 20,000 years. And we know the h, the half-life, 5,730. So it's going to take a little bit of algebra to solve this one, but we'll still figure it all out. First thing we need to do is let's reduce that exponent down a little bit. 20,000 divided by 5,730 ends up being roughly 3.49, or I'm just going to call it 3.5. All right, so again, let's do some algebra. Let's do the part we can do. We can do 1/2 to the 3.5 power. So 0.5 to the 3.5 power. I end up getting 0.088. And now if I'm trying to solve, I would divide both sides by the 0.088 number, and I will have my initial amount. So 10 divided by 0.088, we're looking at roughly 113.6. So let's answer this word problem with words. 113.6 what? So, how much did okay, that's how much it had at the beginning. So 113.6 grams of carbon is how much it started with 20,000 years ago. If now it's down to 10. All right. So again, we can work these problems a couple of different ways. Your work today will ask you both kinds of questions. The easier one, like that first example, and then a little bit harder algebra one, like this one. All right. Let me know if you need any help. Again, you know how to get a hold of me. Good luck.